Okay, let's try this next question. This one's a little bit challenging because it's one of those system of equation questions. So we're told that the graph has a turning stationary point at -2 and 9. So if we take -2 and we put it into here, we get out 9. But if we take the derivative of it and put -2 in, the derivative, the gradient, will be 0. So we can put a 0 in for the derivative. And that's how we build the two equations. Y equals px cubed, we've got that. So we can put -2 into the original equation. So instead of x, see that -2 coming up, we just work it all out. Well, that'll be -8. That'll be 4 times 5 is 20. That'll be 2q. And then all we have to do is 20 minus 3 is 17. And then we could subtract 9 from, yeah, I think that's right, 17. And then if we subtract 9 from 17, we're going to get 8. And then we'd add the 8p over here and subtract 2q. Hey, divide everything by 2. Now that's the simplest, a nice little equation in p and q we can have. Now that's just using the original equation. Let's find the derivative of this function. Well, it's the whole derivative thing, 3 times p, and bring that down, 1x squared. 2 times 5 is 10x. 1 times minus q is minus q. There's the derivative. But hey, at -2, we know the derivative is 0, so we can put a 0 there. And then put in -2, we're going to get a new function. There's 12p, that's -20, so we can add 20 minus q. There's our other equation. Now, all we do is put those two equations together. The 12p minus q, the 4p minus q. Hey, this minus q is all set up so nicely that if I subtract 20 minus 4, I get 16. Minus q minus minus q is no q's at all. Minus q plus q is 0. And 12p minus 4p is 8p. Divide by 8, I've got p. I just figured it out. Hooray. How do I get q? Well, I can just put 2 back in here, and I get 8, 4 times 2, and then I subtract, I get minus q equals -4, so q must be 4. Q must be 4, and that makes sense. 2 times 4 minus 4, so q must be 4. Well, I've got p and q there, so I've got the equation. And I just like to put it into GeoGebra and like, hey, what does this thing look like? Well, there it is. There's the turning point at 2, -2 and 9. This is the actual thing. And it's if we put a 2 in front for P and then a 5 and then a -4 for Q, look, it makes it all work out nicely. Well, yeah, it makes it true. Okay, there you go.